Hi everyone, thanks for watching my YouTube contents. I'm Sangwoo Kim. Today I would like to show you how to do goodness of fit tests for Cox proportional hazard analysis in XLNR. In the previous video, I showed you how to calculate covariance matrix in XLNR. I think this covariance matrix is crucial part to clearly understand how to do goodness of fit test in XLNR, right? So please refer to that previous video if you want to know more about how to calculate covariance matrix. But in this video, I would like to focus on how to do goodness of fit test in XLNR. In our program, once you have proportional hazard model, which is named as CPH1, then when you use summary function, then you can get these coefficients, and also at the bottom of the result, you can see three goodness of fit test results, right? So this is how to interpret the results. Under 5% significance level, these are all significant. So it means that at least one independent variable is significant for proportional hazard model. The great part, actually, I showed you how to calculate these three statistics manually in our program, right? So likely ratio test can be calculated from log likelihood from null hypothesis, null model, and final actual model. Wald test, as you can see, this is the matrix computation, and the middle part, actually, you need to calculate information matrix. Information matrix is actually from covariance matrix from Cox proportional hazard model, and you need to use inverse of information matrix. And in terms of score test, you need to calculate detailed score from this model, right? So again, in order to calculate score statistic, you need to use actually a variance matrix from fit zero, this one, right? So I would like to show you how to calculate these three statistics in Excel. Right. Again, in the previous video, as I mentioned, I explained how to calculate covariance matrix from Hessian matrix. So let's skip it for this video. Anyway, let's get covariance matrix from this one. Control C and Control V. And also we need to use covariance matrix from reduced model to calculate the score test. So let's get covariance matrix from reduced model. So you need to set coefficients as 0. Then you can get this covariance matrix. Control C, Control V. Right. And also first part, this one, I would like to show you how to calculate likelihood ratio test. So in this test, we need two different sum of log likelihood. So these are from null hypothesis. Okay. Let's get coefficients from by using solver. Okay. And this is sum of log likelihood from this model. Right. Then likelihood ratio test 2 times null hypothesis minus find our model hypothesis model likelihood ratio. It's better to use 2 times full model, full model minus null model. Okay, Then degrees of freedom is 2 because there are two independent variables, and p-values can be calculated by 1 minus chi-square distribution, degrees of freedom, true. Okay, this one. Okay. Then let's get Wald test statistic. This one. It can be calculated by using this formula. So merge and transpose of regression coefficients, this one, and inverse of covariance matrix, and merge, comma, and coefficients, and press Ctrl Shift Enter. Then degrees of freedom 2, and we can apply same p-value formula for Wald test result. Okay, and score test can be calculated by using score vector. This score vector can be calculated from this one. So let me use this formula. Okay, so I want to show you how to calculate these parts in here. So a underscore ik can be for Rx variable can be calculated by sum of Rx fixed final cell and count for Rx variable fix the final cell, last cell, and Ctrl C and Ctrl V. Then AIK for age variable, sum of and count of age variable, and fix the last cell. Then score for Rx, this one should be used for Rx minus AIK for Rx variable, and score for age can be calculated by age variable minus AIK for age variable. Okay. Ctrl C and Ctrl V. Right. Then we need to consider event case. So sum if range from column B and criteria as 1, and some range from column L. Okay. And for age, sum if range from column B, comma 1 as criteria, and some range from column M. Then score test can be calculated by merge or transpose X variable, this one, and comma, and covariance matrix from reduced model, this one, and merge, comma, coefficients, and press Ctrl Shift Enter. Sorry, it should be sorry, let's calculate again, and merge transpose of score vector. Sorry, I used these coefficients, but we need to use score vector. This one, comma, covariance matrix from reduced model, and emerge, comma, score vector. Then press Ctrl Shift Enter. Right, which is same as our output, and degrees of freedom is 2, and p-value we can use same formula, okay, which is same as our output. Alright, that's it for today. So in summary, in order to calculate standard errors, in order to calculate goodness fit test statistic, we need to understand how to calculate covariance matrix and covariance matrix from reduced model, right? Then we can calculate the Wald test and score test statistic. Actually, likelihood ratio test statistic can be calculated from two sum of log likelihood from null model and full model, this one. Then we can calculate p-value. So it means that actually this is goodness of fit test. So under 5% significance level, we can say that this at least one independent variables are significant. So it helps to increase goodness of fit test. Goodness of fit of Cox proportional hazard model. I hope it was useful to understand how to calculate the three goodness of fit test statistic and also how to interpret it. Please click like and subscribe if it was useful for you. Thank you.